Chapter 7, Permutation and Combination. So for this chapter, we are going to have two subtopics, which is the first one is 7.1 permutation and the second one 7.2 combination. For the first lecture, we are going to focus on permutation. So the learning outcome for this lecture, at the end of the lesson, students should be able to use the technique of counting, find the number of permutations of n different objects, and find the number of permutation of R object from n different objects, and find the number of permutations of n object comprising of R1 identical object of type 1, R2 identical object of type 2, and RK identical object of type K, where the total R1 plus R2 plus ... up to Rn is equal to Rk is equal to n. Technique of counting. If an event has m steps, of which the first step can be performed in n1 different ways, the second in n2 different ways, the third in n3 different ways, etc., then the whole event can be performed in n1 multiplied by n2 multiplied by n3 up to nm. How many steps? M steps. So we have mn, m number of n, different ways. For example, in a computer game, there are two tunnels leading from a point A to point B. So from point A going to point B, we have two choices, right? 1 and 2. And then from point B to point C, we have three tunnels. 1, 2, 3. 1, 2, 3. And now from C to D, we have four tunnels. 1, 2, 3, 4. Okay, 1, 2, 3, 4. So how many ways that we can go to calculate the number of routes to move from point A to point C via point B? So we either take A by using route 1 to B, and then from B, route 1 to C. So that is the first way, right? And then the second way is A to B is by using tunnel 1, and then B to C by using tunnel 2. So that is the second choices, the second ways. And then the next one is when A by using the first tunnel, and from B by using the third tunnel. So if we want to use from A to B by using the first tunnel only, we have three types of from B to C. Okay, so that's why what we need to do, we just have to multiply of the n. So this is n1, this is n2, this is n3, where there are three steps here. Our m is equal to 3, following the definition. Okay, so how to calculate this? For question A, the number of ways should be 2 tunnels multiplied with 3 tunnels, 3 choices. So that's why 2 multiplied by 3. So if I represent it 1, 2, from A to B is 1 and 2, and from B to C it will be A, B, C. So the combination will be A1, 1A, 1B, 1C, and then 2A, 2B, 2C. So we have 2 choices. That's why the number of ways should be, the number of ways should be 6. Okay, so question B. Calculate the number of routes to move from point A to point D via point B and C. So what you need to do, we just multiply all the tunnels we have. So which is, for going to tunnel A to B, we have 2 choices. This is A to B. And then from B to C, we have 3 choices. And from C to D, we have 4 choices. So just multiply all these choices. So what do we have? So we have 24 as the result. Okay. Definition of permutation. So this is the second learning outcome for today. A permutation is an ordered arrangement of objects without repetition in a set of objects. For example, there are 6 permutations of letter A, B, C. So A, B, C are different from each other. So we can have how many ways to arrange these 3 letters? Okay, the first choices is A, B, C, and then A, C, B, and then B, A, C, and then B, C, A, and then C, A, B, and C, B, A. So from three, what is this? 3 letters, we want to rearrange this. So first place, okay, this is technique counting. First place here, so how many choices? We have A, B, and C. So we have 3 choices. So for the second place here, so what is remain? So let's say we have choose A here. So we have B and C only. Means that we have only 2 choices for the second place. And then last one, we have only 1 choices. Okay, so this is by using counting technique. But how about by using the permutation? Okay, so the number of permutation of n different objects taken at all a time without repetition is npn, which is equal to n factorial. What is n factorial? It is equal to n multiplied with the value less 1 by n, which is n minus 1, and then multiply with n less than by 2 from the value of n, which is n minus 2, and so on up to multiply by 2 and multiply by 1. Okay, so this is what we have done previously, which is by using the counting technique. So note that if 0 factorial is equal to 1 and npn is equal to n factorial, means that the product of all the integers from 1 to n inclusive, and it is called n factorial. Example 2. How many different 4-digit numbers can be formed from the digit 5, 6, 7, 8? So we might have 5,000 something something, or 6,000 something something, or 7,000 something something. So how do we rearrange these digits to get 4-digit number? So 4-digit number means thousands number lah. So the first is, you can, because it is all different numbers, means that we can directly just choose for P4. Or another method is, it will be 4 factorial. Why? Because for the first place, it should be 4 choices. So we have 1, 2, 3, 4. And then for the second place, because we have choose 1 for the first place, we left with 3 digit. Right? And then for the second place, we left with 2 digit. And for the last place, we have only 1 choices. 1 choice. Okay, that's why it's 4 multiplied by 3 multiplied by 2 multiplied by 1, which is equivalent to 4 factorial. Number of permutation of R object taken from n different objects. So now we have n different objects, but we only choose R object, which is this R is less than or equal to n. So what is the permutation? The number of permutation of n different objects taken R, which is R is less than or equal to n at a times is npr, where npr is equal to n factorial divided with n minus r factorial. So if we have npn, so the formula will be n factorial divided with n minus n factorial. So n minus n factorial is 0 factorial, which is equal to 1. That's why npn is equal to n factorial. If there is no restriction, means that the repetition is allowed, the number of ways is n to the power of r. Why? Because we can repeat the choices. So the first place, it will be n choices. And then multiply with the second place, because we can use the object that we have choose earlier, means that the choices is also n. So if it's for r times, so it will be n multiplied by n. For how many times? For r times. So for r times means that this n multiplied by r term. That's why the answer will be n to the power of r. Example 3. how many three-letter words can be formed from the letters in the word absolute? Okay, so how many letters in this word? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 letters. So what we want to choose, what we want to form is only 3-letter words. So we have 3 places for the 3-letter words. So it will be the first place. How many choices we have? 1, 2, 3. All of these can be the choices lah. So we have 8 choices, right? And then multiply with the second place. If we have choose 1 for the first place, means that the letter that will remain is only 7. That's why we multiply by 7, and here will be multiplied by 6. Okay. Or another way to answer this question is by using the NPR. So what is our N? N is equal to 8, and our R, the one we want to choose to form, is only 3-letter word. So 8P3 equal to 336. This answer will be the same lah. So what is 8P3? So 8P3 is 8 factorial divided with N 8 minus 3 factorial. So what we have is actually 8 factorial divided with 8 minus 3 is 5 factorial. So what is 5 factorial? Actually, this 8 factorial can be written in a, yes, because it is a 5 factorial. 5 factorial is including from 1 to 5. And then what's left? We have 6 multiplied by 7 multiplied by 8. It will be 8 factorial and divide with 5 factorial. So 5 factorial divided by 5 factorial, so we left with 6 multiplied by 7 multiplied by 8, which is will give the same answer as 8P3 and 8 multiplied by 7 multiplied by 6. Okay. Okay. Example 4. There were 7 empty seats when 4 passengers boarded a bus. In how many ways can they be seated? Okay, so we have 6, 7, 1, 2, 3, 4, 5, 6, 7. So passenger 1 can be here, or here, or here, or here, or here, or here. But we are not fully use all the empty seat because the people we have is only 4 people. So what we need to do? Yes, we can use the permutation of R object from N objects. Okay. So, what is the answer for this question? Okay, so how can we choose the ways? So the different ways is 7P4. Why? Because we are arranging 4 passengers on 7 empty chairs, 7 empty seats. So there are 7 choices for the 4 passengers. That's why we have 7P factorial. Or you can use the 4 person that want to sit. So the first person can choose between 7 seats. And then the second person, so the seats left is 6 only. So that's why we have 6 choices. And the third person will have 5 choices. And the last person will have only 4 choices. Okay. Permutation of an object comprising of R1, R2 up to RK identical objects. So this is the learning outcome D. So let's say the number of the permutation of an object comprising of R1 identical objects of type 1, R2 identical object of type 2, RK up to RK identical object of type K, where R1 plus R2 plus so on equal to N is N factorial divided with R1 factorial, R2 factorial up to RK factorial. Why? Because the identical objects cannot be distinguished, like letter P in PPAP and so on. So we have to divide the arrangement of the identical objects. So example 5. Find the number of arrangement of the following word. So for A we have lotto. So we can arrange all these 5 letters. But if we change the place between these 2 T, so the word still be lotto. And if we change the place between these two O, so it will give you the same lotto word. So what we need to do, we have to divide with the identical item. So to arrange these 5 letters, it will be 5 factorial. So we have identical O word or letter, so it will be 2 factorial, and then identical 2 of T letters, then it will be 2 factorial. So the answer should be, yes, 5 factorial divided with 2 factorial, 2 factorial. And the answer will be 30 only. Next, for question B, mathematics. So how many M in the mathematics? We have 2M, right? That is the identical. And then, what else we have? What else we have? We have A, 2A. And then, we have T, 2T. And then, H, we don't have repeated H. E, we don't have it. I don't. C don't. S don't. So the identical letters here is only M, A, and T, right? So how many letters in the mathematics? If we want to arrange all, so it will be 11 letters. So we rearrange 11 letters, and we have to divide with 2 identical M, 2 identical A, and 2 identical, this one is forgot, 2 identical T, which is equal to 2 factorial. So that's why the answer will be 11 factorial divided with 2 factorial, 2 factorial, 2 factorial. Okay, so the answer is 4,989,600. Wow. Thank you. That's all for lecture 1. So we are going to continue with lecture 2 of permutation on the next session. Okay.